Great, so let's go ahead and do a little reflection activities. So if you haven't already get a blank piece of paper, and just in the top corner, go ahead and draw a triangle. So it does also help. If you want, you can use a ruler, but otherwise we can also just fold our papers. And so when you have a reflection across a certain line, there's a lot of opportunity, especially like given this blank paper. So some examples are, I could reflect this triangle across this line here. And again, when you think of reflection, you're going to want to think of like a mirror image of it. I could also then reflect this triangle across this way and do like a mirror there. There's also the possibilities of diagonal reflections and reflect it across that line, or reflect it this way across this line here. So we're just going to start off with a basic reflection, and I'm just going to kind of create a line that I'm going to use as a guide to fold over. So you can take your paper and do just that. It doesn't have to be exact. But you can fold it over. So there's just a faint outline, and sometimes it helps if you put it up to the mirror or to window or anything like that, and you can just barely see it. And so one way, and there's a lot of different ways you can go about doing this, is that if you trace over this, and trace over it kind of heavily, when you open up your piece of paper, you'll notice that it actually reflects, and then you can just kind of darken it in. And so you have to do this with a pencil, and I did this line pretty heavy, and there you go. This is actually a reflection, and if this was a true thing, this could be a y-axis if you had something like that for your graph. So important things to think about when you do reflection is this distance here. Okay? If this distance here was, let's just say, 2 centimeters or something along those lines, then how long do you think this distance is here from this point of reflection to this point here? Okay. So chances are it's going to be 2 as well. So let's say this one is a little bit more bent away, so let's say this one happens to be, we'll just say 3, just for our example. So from this point to this point, what do you think that distance is going to be? And so hopefully you also would agree that it's going to be 3. So the same thing goes from here to here. That these distances between them are all going to be congruent between our original shape and the reflection. Alright, so let's try another one. So I'm just moving over next to it. And I am going to draw a rectangle. Okay, so kind of a darkened rectangle. Make sure it's got some good amount of silhouette on it. So now I'm going to actually reflect it what could be initially across an x-axis over here. So go ahead and we're going to fold the paper over, and it doesn't really matter how you fold it over, as long as you try to just keep it so that way the edges are straight. Just a nice fold. Okay, and so hopefully you're following along, and you should be able to faintly see your shape through the paper. And let's actually see if I shut off the light, if it's more visible. A little bit. Okay, poor Elmo's having a hard time trying to figure out what it's supposed to be focusing on. So what you can do is then again, just kind of trace over it on the back side, pushing down. And so when you open it up, come on, there we go. You'll have the faint outline, which we can then go in and darken, of our graph here. So sweet. And so again, we can kind of say, okay, well, this point to this point, this point to this point, and then we had our line of reflection. Now, last time we talked about was the fact that this distance was the same and was congruent both here, from here to here, and here to here were congruent. Okay? From the point to the line of symmetry to the line of symmetry to the next point are the equal. But I want you to look at something else on this example. If you had to take a guess as to what the degree was here, what would you say? What angle do you think that these look like they are intersecting at? So how many degrees? And if you want to, you can actually get out a protractor and you can measure it. Pause the video. So if you got out your protractor and actually measured it, what you'd find is that this intersects at 90 degrees. And even if you were to come back here, these ones here also intersect at 90 degrees. So we're going to actually touch on a vocabulary word that we used in the past of lines that intersect at 90 degrees and cut it into two congruent pieces or bisect it is the perpendicular bisector. And yes, go ahead and write this down on your paper, because that's part of the notes and the comprehension. That the line of symmetry that you use to reflect an object across it is actually going to be a perpendicular bisector. And even if these parts are further away, just kind of like over here, where even though these were further away, it still does the initial line itself. These are all parallel, which means they'll never intersect. They'll look hopefully prettier than these guys do. And the line of symmetry is the perpendicular bisector of it. So let's see what we got next. How about we come down to our corner, right hand corner is what I'm going to be looking out of. I can kind of zoom out so we can see this. There we go. So I am going to do, we'll just do another triangle, just kind of make things easy on that factor. Now, what we're going to do on this one is, if you haven't already, go get yourself a ruler. And we are going to try to construct this one and to see if we can actually make its reflection without actually folding it over, and see if we can check it from there. So we've learned that the line of symmetry, whatever it is, has to be a perpendicular bisector, and that all of our lines are going to be parallel, and it's going to cut it in half. So you can take your ruler, and let's start off by drawing a line segment. And I'm going to do my line segment for 1 inch based off of my base here. Okay, so if it's a perpendicular bisector, that means that it's going to cut this one in half. So I'm going to find my halfway mark between here and here. So my 4 to my 5, so 4.5 is there. And so now what you can actually do is you take your ruler, and it works if you do a long line, and I'm going to actually use just this mark here. It doesn't really matter. If I wanted to, I could use the mark on the 8. I'm just going to use that mark there, and I'm going to line it up. So what that means is I've now created a 90-degree angle. And since I've created a 90-degree angle, I can then draw this guy here because he is 90 degrees and he cuts this line segment in half. So now all I have to do is duplicate these points. So for me, this point here goes from 4 to 5 1/4. So 1 1/4. So if you notice, I'm keeping my line up. If I'm going too quickly, feel free to pause the video. I'm keeping the line of my 4 on this line, and I'm going to go over 1 1/4. Draw my point there. And let's come up and see this guy. So again, I'm just going to use my 4 for my measurement. He's a little bit off, but I'm going to call him right here. That's basically what he's at. So 1, 2, 3, 4 is what I got going on there. So I'm going to do the same thing over here. 1, 2, 3, 4. This is just little cheats. Okay, so there's my points. And let's connect my points and see what I get. Of course, this one's going to be a little bit prettier because I actually used a ruler this time instead of just freehanding it. But we have a line of symmetry, and we've created the reflection. Now to test this, you can actually fold it over one way or the other. One way that you can do this as a cheat is you fold it over with the line facing up, so you can actually check it. And either you can hold it up to the light and see how accurate you were, or now that you have a crease, you can actually do what we did last time, and you can reverse this crease and again lay it over and see what happens. And if you want to, you can even trace it and see how your imprint from last time works this time. And in that point, I was a little off, but at that point I was a little off over here too. But otherwise, what you'll find is that it is in fact the reflection, because the line of symmetry that it reflects across is a perpendicular bisector. Sweet. So we have reflected, recognized perpendicular bisector. Please Note that if I'm reflecting across the y-axis, if this happened to have been 2, 4, this point over here would have to have the same y, but now is a negative x. So my point would have flipped over and my sign changed. So when you have a reflection across the y-axis, you get a negative x. Your x changes its sign, but your y's stay the same. Okay. Over here, I had a reflection across the x-axis. So if this point here, we'll just do this one over here, sure. This point over here happened to be, let's say, 5, 3, and I reflected it across the x, my distance over is still going to be the same, and go ahead and write these down. So I'm still going to travel the same amount for my x, but now my y has gone from a positive y to the same distance of a negative y. So a reflection across the x-axis has an x comma negative y. And we'll talk more about the diagonal ones in a moment. This is not a traditional direction that usually they translate it. Usually they translate it more and reflect it across the y equals x. But, and like I said, we'll talk more about these because it'll be a little bit easier on an actual graph picture. But you can kind of go ahead and imagine how that might look and what would happen to your points. Right now, these are the two ones that we wanted to focus on, and there you go. So that's reflection. I hope this helped.